Hello students, welcome to our channel. Today we are going to study about lenses. We have discussed about the lens, that what are lenses and what kind of images are formed. We have studied about the ray diagrams, and now we are continuing our lecture with some questions, and then we will see the use of convex and concave lens. With that we will study the ray diagram for concave lens. So here question number 1, where should an object be placed in front of a convex lens to get a real image of the size of object? At principal focus, at twice the focal length, at infinity, between the optical center of the lens and its principal focus. So here answer is at twice the focal length, where we can see the object when we want a real image, when we want to get a real image. So it is at the twice of focal length, means at center of curvature. One half of a convex lens, it's very important question. One half of a convex lens is covered with a black paper. Will this lens produce a complete image? Justify your answer. So here lens will produce a complete image of the object. Intensity of image is reduced because rays from the top portion of the lens only are refracted and form the image, right? So if it is covered from here, it will form an image, but only the intensity of image that is reduced here. Now, question is figure below show a point source of the light S. Here you can see S, a convex lens L, and a plane mirror M, right? So, three are places that ray of light from S return to it after reflection from M. Here we say that what is the distance OS called? From O to S. O to S, from this optical center to S. So as you observe, the light when refracted, it will meet at one point, we called it focus, and the distance from O to S, it is called focal length. Question is to which point left of S on S or right of S will the ray return if M is moved to the left and brought in contact with the L. So here the ray will still return to the same point S, right, as shown in the diagram. Now question is a student set up the apparatus for determining the focal length of convex lens as shown in the figure. She told her friend that the approximate focal length of lens was 10 centimeter. She asked him to place the screen so that image of distant object is obtained on it by slight adjustment. He placed the screen at the mark of, so where she can place it at 30 plus f, that is equals to 40, right? Now let's revise all the lens rays diagram in just 3 minutes. So where we have placed the object first at infinity. At infinity, if we place any object, we see the image formed it at focus. Size of image, we say it's a point size. Nature, we say that it is real and inverted. Second, when it is at focus f1. When the object we place at f1, then one line will be parallel to the principal axis, passes through f2, and another line which get undeviated passes through it. So here you observe when it is at f1, it form an image at infinity, and very large image will be formed, and it is real and inverted. Now next case we are taking the object between f1 and 2f1. So if it is between 2f1 and f1, it is forming image beyond 2f2. Here in this, it forms a large image, nature that is real and inverted. Next case, we are taking it beyond 2f1. So beyond 2f1, we see that it forms an image between f2 and 2f2. It's a smaller image and real and inverted. Next case, we are taking the image object at 2f1. So if it is at 2f1, the image formed at 2f2. Size of image that will be same, and nature we say that is real and inverted. Last case we are taking it between f1 and O, that is optical center in f1. So in this case we get image on the same side of the lens. It is very large, large image is formed, and we say it is virtual and direct. So out of these all, only one case is there when the object is between f1 and O, and then we say we have a virtual image. Except this, all images which are formed in this case that is real and inverted. Now let's understand the use of convex lenses. So here making a microscope, telescope and slide projector, making a simple camera as a magnifying lens by watchmakers, used in spectacles to correct the defect of vision called hypermetropia. Now let's understand ray diagram. Rules for making ray diagrams. First rule, that is a ray of light which is parallel to principal axis of a convex lens appear to be coming from this focus after refraction through the lens. So here we are taking a concave lens. Line which is passing through this, it appear to come from focus, right? Second, we have a ray of light passing through optical center. It passes through optical center undeviated, means straight. Third, a ray of light going toward the focus of a concave lens become parallel to principal axis after refraction through the lens, right? Which is appears to be passing through focus, it will move parallel to the principal axis. Now let's take object and infinity. Here we are taking of any AB. Now these lines are parallel to the principal axis. We observe that it diverges and appears to become from F. So the image formation, it is at focus. Nature of image, we say it's virtual and erect image and point size. Now let's take object between 2f1 and f1. We are taking an object between f1 and 2f1. So now if the ray of incident ray is parallel to the principal axis, it diverges and then it moves back and it appears to come from focus. A ray after refraction passes through undeviated through the lens, and where they will meet, that will be the image formation p dash q dash. So here what is the position of image? It is at f focus. Nature of image virtual, erect and smaller in size. Now let's understand the use of concave lenses. So this concave lens used as eye lens in Galilean telescope, used in combination with the convex lens to make high quality lens system for optical instruments. These lenses used in a wide angle spy-hole indoors. These are used in spectacles to correct the defect of eye. Defect of vision, we call it myopia. Now let's understand some question. Draw the pathway of light after its incidence on the lens mirror in the following figure. So here what first is, we say the line which is passing through the focus, it will always we say it moves parallel to the principal axis. Second line, if it is passing through focus, it again passes or bends parallel to the principal axis. Another one, we have a convex lens. From this, a line which is passing through optical center get undeviated. What type of lens must be placed at xy so that image I shift to I dash? So here we are taking this concave lens. What type of lens must be placed at xy? Here, right? So that the image I shift to I dash. So these are this I and then I dash. So this type of lens, that is concave lens. A concave lens made of material of refractive index N1 is kept in a medium of refractive index N2 A parallel beam of light is incident on the lenses, complete the path of a ray of light emerging from concave lens, n1 greater than n2. So if refractive index of 1 is greater than n2, we say the light is moving from rarer to denser medium, from rarer to denser. So therefore, in passing through concave lens, it diverges because it bends away from the normal. Now let's understand this. Study the ray diagram, name the device X and Y, the focal length respectively. So here device X is a convex lens. Why? Because it all the lines meet at a point, it forms a image on the screen. Device Y is a concave lens of focal length 20 centimeter. Question is, which of the following lens would you prefer to use while reading small letter found in a dictionary? A convex lens of focal length 50, a concave lens of focal length 50, a convex lens of focal length 5, a concave lens of focal length 5. So answer is here, a convex lens of focal length 5. So this is all about, you need to revise this question. Thank you. Bye bye. If you like the video, please share it with your friends, subscribe the channel so that you will get the notification of the new videos.